For far too long, we were using mostly, or maybe even exclusively, permanent environments. We would have a permanent production, permanent pre-production, permanent development, and so on and so forth. And that needs to stop right now. Long time ago, I worked exclusively with permanent environments. We had permanent production, permanent staging, permanent testing, permanent development, so on and so forth. Today, I will argue that the only permanent environment should be production. Everything, and I mean everything else, should be ephemeral or temporary. All other environments should be created when needed, in any quantity we need, and destroyed when not used. Otherwise, we are either wasting time or we are wasting money, or both of those things. Now, you might be asking yourself, what's wrong with having permanent staging environment or development environment? That's a good question. Thank you for asking. Most of the permanent environments, except production, tend to limit productivity or to cost too much. And now, before I explain why, let me break them into categories. To begin with, we have permanent environments used for testing before something is deployed to production. I will call it pre-production. You might call it staging or something else. It's the environment where we test the new version of an application together with the rest of the system in a production-like setting. Then we have feature environments used to test a new feature or a new release before it starts its journey to production. Those environments are usually used for a relatively short period of time, or to be more precise, for testing of a specific feature that should not take long, typically minutes, maybe hours if you go crazy, maybe days, but please don't do days. Anyways, certainly not weeks or months. Then we have the third group, which I will call development environments. Those are used by developers to test their work in progress before creating a pull request or pushing changes to some intermediary branch like development or staging. Now, and here comes the important thing. In most cases, none of those should be permanent, but for different reasons. To begin with, pre-production environments are not used all the time, or at least they should not be used all the time. They come into play at the end of the process, when we are ready to deploy something to production and we want to do the last set of tests, those that benefit from having the whole system in almost the same state as production. So, if pre-production is not used all the time, we are wasting money by keeping it running all the time. That is certainly true when using cloud providers like AWS, Azure, or Google Cloud, but also when in on-premise data centers. Even if you're not paying for usage of resources, you are paying for having more than you need. Those servers could be used for something else, but not used for pre-production. Now, you might say, okay, true, but destroying pre-production means that we need to recreate it every time we want to test. If that's the case, then you're doing it wrong. You should be able to create any environment when needed. Otherwise, what is the point of infrastructure as code tools and application manifests? Think of it as an excuse to do better if that's your issue. Now, even if you do find a reason that justifies having a permanent pre-production environment, there is almost certainly no justification for having permanent feature environments. You might be used to deploying new features to a staging environment or to a development environment or what you call it environment, but that is creating delays and causing conflicts. If you have a single or a few staging environments, you need to waste time on coordination or creating queues. This feature is waiting for that feature and you cannot do this before somebody else does that, and so on and so forth. If that's not the case, then someone might be overwriting someone else's work, because either we are queuing and waiting for somebody to finish doing something on some environment, if it's permanent, or we are overwriting somebody else's work, and then that somebody else cannot continue doing whatever he or she is doing. The ideal situation is to create a new environment for every single feature, often based on every single feature branch and triggered by a pull request. That way, you can test any number of features in parallel without any conflicts. Isn't that awesome? Based on the results of the tests, you can decide what should continue towards production and what should be fixed or even discarded. Now, most people do not create a new environment for each feature or pull request because that's too expensive. Or to be more precise, because they think it is more expensive. And they are right, but only and exclusively if those environments are permanent. That would, indeed, be extremely, very expensive, since that would mean that there are as many permanently running environments, like clusters, as the maximum number of pull requests we might have at any given moment. On top of that, that would require a lot of coordination. If I create a new pull request, someone or something needs to figure out which permanent environment is currently not used and then put it there. As you can guess, the solution is to have not permanent but temporary or ephemeral environments. We should be able to create a new environment whenever a pull request is created and destroy it when the pull request is merged or closed. It's as easy as that. You have a new pull request, create an environment. Pull request is closed or merged, destroy the environment. Finally, we have development environments. There is an even bigger need to have as many of those as needed and for them to be ephemeral. If we could potentially have many preview environments, we are certainly going to have even more development environments. Every single developer should be able to work independently of any other, of anybody else. The idea that we all share the same development environment is just silly. I need to wait for Joe to finish his work before I can start mine, and Michael needs to wait for both Joe and me. Again, that's silly. All of us should be able to have our own development environments, and to make things even more complicated, each of us might need to have more than one, since we might be working on multiple applications or multiple features or multiple projects or whatever we're doing. You get the point, right? Now you might be saying, hey, shouldn't you use your laptop as a development environment? Maybe you should, or maybe you shouldn't. If you should, you might still need more than that. But we'll talk about all that later. All in all, only production should be permanent. Everything else should be temporary, created when needed, destroyed when not in use, and there should be as many or as few as needed. Now, everything I said might sound nice and dandy, but what really matters is not only what should be done, but how to do it. So let's talk in more detail about each of the environments, excluding production, and how we might want to set them up. The most common way to develop applications is to simply open your laptop, open your favorite IDE, and start coding. That's the easiest and most common way to have a development environment. Every once in a while, you're likely going to build your application, to run it, and to test it. And that's great. We all do that. But what do we do when we need to deploy dependencies? We might need a database. And that's fine. We can run a database locally, or we can run it as a container with Docker or Podman or Branch Desktop or whatever you're using. But what if we need a message broker? Maybe we need a couple of other applications. Maybe we need a whole cluster. That's when things get complicated. We can't run a cluster with the whole system on our laptops. I mean, maybe some of us can if we have beefy enough hardware with a lot of memory and CPU, or maybe we can't. Maybe everything we need requires more resources than what a laptop has. Or maybe it is too much hassle to set everything up locally. So, what can we do? One model is to combine local with remote development. We can run the application we are working on locally and connect it to dependencies like databases or message brokers or other applications and so on and so forth that are running remotely. But the question is, how do we do that? How do we instruct our application running locally to connect to a database running remotely? Do we just open the ports of the database to the outside world? No, please don't do that. It is messy and it is insecure. Moreover, it is likely not going to work even if you open the ports. Why? Well, because the communication often goes in both directions. If, for example, you're working on a front-end application, you might need to instruct it to connect to an API of a remote backend. That's easy. If you're working on the backend, you might need to connect it to the remote database. Again, that is not so hard. But if you're working on a backend, you might need to enable the remote frontend to connect to that backend. How do you do that? How do you instruct a frontend running somewhere else to connect to the backend running on your laptop, which probably does not have an IP accessible from the cluster where that frontend is running? Even if you do manage to connect those, how do you make sure that the frontend is not going to disrupt others? Remember, that frontend should use the backend running on your laptop, but only for you. Others using that same frontend should continue experiencing the same behavior as before. And that's where tools like telepresence come in. Telepresence can enable communication with remote services in a way that they appear to be local. From the perspective of your application running locally, it would seem like it is connecting to a database or a message broker or any other service running locally, even though it's not. Telepresence and other similar tools solve the problem of combining local development with remote services. And that's absolutely great. But in some cases, you might not want to run your application locally at all. Maybe everything, including the application you're working on, should be running remotely. Why not? Common ways to run applications remotely are Docker Desktop, Minikube, Rancher Desktop, Kind, and many others. By the way, I have videos on some of those. Now I'm waiting for you to understand what I just said. You might be saying, hey, stop. Those are not remote clusters. They are on my laptop, right? That's right. That's true. Technically, those run on your laptop, but they are in a way remote as well. All those are running in virtual machines, and our local client needs to connect to those machines in more or less the same way as if they're running somewhere else. For local clients, there is hardly any difference between connecting to a virtual machine on a laptop or on some server or anywhere else. If your workloads are running in a cluster that sits on top of one or more virtual machines, it does not matter much whether those VMs are here or there. The only difference is that it is slightly, but only slightly, easier to mount local volumes in a VM running on your laptop than in a VM running somewhere else. But that does not matter much, since most of the solutions we'll explore soon are synchronizing files into those VMs, no matter whether they're here or there, and they're doing that rather than mounting local volumes. Mounting volumes is not a good idea. So it does not matter much whether, while developing, we deploy our applications to a cluster running on top of a VM, running on top of our laptop, or a cluster on top of a VM running somewhere else. Now, there is one significant difference though. It might be too expensive to create a real cluster for every single developer, right? If they run for a long time, that might be too much of a cost. If we create real clusters when we need them and destroy them when we don't, that might be too much of a hassle, and it might even take too much time. For example, it can take around 20 minutes to create an AWS EKS cluster, and when you do create it, you're paying not only for worker nodes where the applications are running, but also for control plane nodes. Now, that's not too much for a permanent cluster. Heck, you can wait 20 minutes for a production, but it is too much for a temporary cluster that is multiplied by a large number of environments. I wanted, no, wait, that's wrong. I needed to be fast and cheap. So creating real clusters is too slow, too expensive, and too much of a hassle. Does that mean that we should abandon the idea? No, it does not. We can have a real cluster and give everyone a personal namespace. That, however, poses its own set of problems. To begin with, multi-tenancy does not work well when splitting only based on namespaces. For that, we can use something like, let's say, Capsule. There's a logo over there, which gives us multi-tenancy based on namespaces. Or we can abandon the idea of giving everyone a namespace and give everyone a whole big, beefy cluster, but not a real one. We can give everyone a virtual cluster with something like vCluster. vCluster is a tool that allows us to create virtual clusters on top of real clusters. It gives us better isolation than namespaces, and it is very, very fast to create. With a single command, we can have a virtual cluster up and running in a few seconds. From the user perspective, let's say developer perspective, it looks and feels and behaves almost exactly like a real cluster, but it is virtual. By the way, check out virtual cluster video if you haven't seen it yet. I'm not going to go into details now. Now that we have different options when clusters are concerned, it can be local VMs, namespaces, and virtual clusters, there is still one more important thing to solve. How can we synchronize our local files on our laptops, our code, with the cluster? I do not want to build a container image, push it to a registry, and deploy it to a cluster every single time I make a change to the code. That is too slow. I want every single change to be instantly available in the cluster, wherever the cluster is. And there is a solution for that as well, and I already gave a hint of what that solution is. We need something to synchronize our local files with containers running in a cluster. That's where solutions like Octeto and DevSpace, by the way, I explored those. That's where those solutions come into play. Among other things that they do, they make sure that whatever we have locally is synchronized with the container running inside of a cluster. Every single change we make locally is instantly available in the container running somewhere else. And that's absolutely awesome. Do you remember the talk about difficulties connecting applications we're working on with dependencies like databases, message brokers, backends, and frontends, and so on and so forth? Well, that's not the problem with this approach. We can deploy all those in our personal namespaces or personal clusters and connect to them from our application. Or we can deploy them in a shared namespaces, or we can deploy them in a shared namespace or a cluster, shared cluster, and all of us or anyone else can connect to them. Or we can combine both approaches. Things become so much easier when we use remote clusters, if that's what we want. Now, before you say, that's exactly what I'll do, let me tell you that there is yet another alternative. We can use cloud SaaS or cloud software as a service solutions as well. We can deploy and synchronize our application to Octeto Cloud, for example. Maybe there is DevSpace Cloud as well. I'm not sure about that one. So we can synchronize it with the tools or types of tools that I mentioned, but managed as SaaS or managed by somebody else. Or we can even go full throttle with SaaS-only solutions like Gitpod or GitHub Codespaces. Those allow us to get a full-blown development environment in cloud managed by somebody else. We can use those environments through our favorite IDEs like VS Code or IntelliJ, or we can even ditch those altogether and use VS Code or equivalent in a browser provided by those services. I'm not fond of VS Code in a browser, but I'm sure that there are people who are. And by the way, if you're interested in Gitpod or GitHub Codespaces, those are available as videos as well, so check them out. And if I didn't mention already, the links to all those videos is in the description, so check that out as well. So you might say, that's even better solution, right? The less I need to manage, the better. But besides the potential cost, there is one more thing to consider. Those solutions do not work well when we need to connect to other dependencies. They work well for single application without a big system type of scenarios. Running an application in Gitpod or GitHub code spaces and connecting to a database running in a separate cluster unrelated to those services is not very secure and can be a bit of a hassle to set up. On the other hand, if all you need is to develop a single application that does not have any dependencies or maybe only a few dependencies, then those solutions are absolutely amazing. Now, let's switch to what happens after we finish developing a feature or a bug fix. So, you're finished developing a feature or a bug fix. You pushed your changes to the repository and you created a pull request, right? We all do that. Now, you're using feature branches and not some silly branching strategy that has development staging and a bunch of other features. And if you're confused, you don't understand what I'm talking about, check out branching strategies video over there. It explains much better than I will do right now. Okay, so I'll assume that you created a pull request and that you want to test your changes before merging them to the mainline, apart from doing code reviews and whatever else you might be doing. How do you test your changes before merging them to the mainline and starting the process that will ultimately result in your changes being deployed to production? Do you deploy it to staging or any other permanent environment? Please don't do that. That would prevent you from having pull requests, since each pull request would override the changes in staging done by the previous pull request. That's not good. What we need is an ephemeral environment that is created for each and every single pull request and destroyed when the pull request is closed or merged. Moreover, any change to the existing pull request should result in changes applied to the associated temporary environment. I will call those preview environments. So, how do we do that? How do we create a separate preview environment for each and every pull request? Well, I already gave you the answer. You can create a new cluster for each pull request and go bankrupt, or you can use Capsule to create a new namespace in an existing cluster, or you can use vCluster to create a new virtual cluster. You can combine those with tools like Octet or DevSpace, but those are not that important in this context, the context of preview environments, since we do not have constant code synchronization. Instead, you can use directly Helm or Customize or whichever tool you're normally using to deploy your application to production. Now, there is one crucial difference between preview and development environments, apart from the need for constant code synchronization. While it is okay or even welcome to manage development environments manually, hopefully through a single CLI command, preview environments should be managed automatically. You need pipelines, and I honestly do not care which pipelines you use. GitHub Actions, GitLab CI/CD, Jenkins, Tekton, Argo Workflows, or any other pipeline solution works just fine. After all they have to do is execute a few commands as a reaction to creation, modification, or closure of a pull request. That's all there is to it. A few commands that are reaction to certain events in GitHub, events related to pull requests. So, you created a pull request, you tested your changes, you performed code reviews, and whatever else you're doing, and the only thing left to do is merge your changes to the mainline. When you do that, two things must happen. Those same pipelines that created the preview environment must destroy it. That part is easy, since all there is to do is either delete a namespace in a Kubernetes cluster or the virtual cluster. Oh, and I almost forgot that you can do more or less the same with Gitpod or GitHub code spaces as well. What matters is that now you're ready to walk the last mile and deploy your changes to production. Now, I said that I'm not going to talk about production, but focus on temporary environments in this video. Yet, here I am talking about production. I will be brief. If you're using Kubernetes, use GitOps tools like Argo CD or Flux, both of them covered. If you're not running your apps in Kubernetes, consider using Kubernetes as a control plane to manage your apps running somewhere else. If you do not want Kubernetes in any shape or form, that's okay as well. There are other ways to run applications and manage them outside Kubernetes, but in those cases, you cannot do GitOps. Now you might be saying, hey, I can do GitOps without Kubernetes, but my answer is no, you can't. There is no single GitOps tool that works outside Kubernetes. And if you don't believe me, I'm ready to fight over it. Let me know in the comments. If you disagree, we're gonna have a fight. Right now, however, I will not go deeper into those tools because this is not about permanent but temporary environments for which GitOps is not, and I repeat, not a good model. So do not use GitOps for ephemeral or temporary environments. Use it only for permanent environments, even though I did claim in the past that you should, but not anymore. Do not. You can fight me over that as well if you want. And one more thing, if you're asking yourself, why use Kubernetes at all for ephemeral environments? Why not Docker Compose? If that's what you're asking, the only thing I can say is watch that video. That's the one. Also, I do not think I mentioned Kubernetes until the very end when I spoke about GitOps. I don't think so. It does not really have to be Kubernetes. The logic that I explained in this video is the same no matter which types of clusters you have, or if you're using SaaS solutions, or if you're operating on the level of individual VMs. The logic is still the same. The tools might change and things might be easier or more complicated depending on what you use. Thank you so much for watching. See you next time. Cheers.